Hello.
Hey, Ben, what's up?
Nothing much.
Ready to come back to school?
No.
No?
Yeah. Even though I was
I hate this. Sitting in a chair all day long, looking at a screen. I much rather prefer in-class teaching.
I guess I can see why for a teacher.
McKinley, did you bring us cookies?
No.
No. Ugh.
Hey, McKinley, can I ask a question of you?
Yeah.
Why weren't you here during the history Zoom? It was just me.
Lunch took a little longer to make than I thought it would.
That's fine.
Yeah, those peanut butter and jelly sandwiches, they're tough.
I actually made shrimp.
What kind of shrimp?
Regular shrimp,
How did you make it?
air fried.
So battered shrimp or just shrimp?
Just shrimp. I didn't put anything on them.
Nothing? No salt, pepper, anything?
No.
What'd you eat them with? Ketchup?
Noodles.
Noodles?
Yes.
All right. I'm having shrimp, I think, Saturday night. That's the plan. All right. Enough talk about food. Questions on the homework?
I have two.
Sure.
All right. The first one is number 10.
Number 10 states the following, that you have an isosceles triangle. Oh, here's an isosceles triangle with a base of 10 and a perimeter P is equal to 36. What do you know about isosceles triangles? And by the way, we got to figure out the area.
So isosceles triangle is meaning that those two sides that we do not know must equal each other. So if we subtract 10 from 36, we get 26. And take 26 divided by 2, we get 13. That's not the part I'm confused about.
I know. So yesterday when we did this problem, we did this. And McKinley figured out that if you do that, we get a triangle. This is going to be my H. This is going to be my 13. And we found out that this side right here would therefore be
5.
All right. Pythagorean Theorem.
I did Pythagorean Theorem, and I got, in its most boldest state, I got I got the square root of 194.
Now, 13 squared is what?
169.
Subtract 25 and you get 144.
Subtract?
Yeah, because a squared plus b squared equals c squared. And 13 is the hypotenuse.
Oh, I see what I did wrong there. All right.
There you go. All right. What was your second one?
Number 6.
Number 6.
I think I might have done this the same.
You probably did.
Yeah. I'll double check my work. Thank you.
All right. 16 squared is 196. So 196 minus 100 would be, no, not minus 100. I saw 10, 10, and 16. Oh, I see. So it would be 100 minus 64, which is 36. So the height would be 6.
For which one? Number 10 or 6?
6.
Okay. So the height is 6 for number 6?
I think so. And then see, 1/2 base. The base would be 16. So 8 times 6. Yeah, 8 times 6, 48. That's the right answer. All right, McKinley, any questions from you?
No.
All right, here are the answers. Number 1 is 29.9 square meters. Number 2, 6 square units. Number 3, 12 square units. And it's the same answer for number 4, 12 square units. Number 5, 16 root 3 square feet. Number 6, we just said, was 48 square units. Number 7 is 40 square units. Number 8, 44 square units. Number 9, 84 square units.
Wouldn't number 8 be 44 and a half because 25 divided by 5 is
I don't know,
25
let's look.
divided by 2 is 12.5.
Let's look. That's a horrible house. But we're left 5, 5, 4, 4, 8. So let's see. Let's cut this and make a triangle and a rectangle. The rectangle is 32. And the triangle, the base would be 8. And the height would be, I don't know. We got to do some work here.
You wouldn't.
That would make that side 4. This would be the height. And this side 5. Yes, Ben?
Why 4? Oh, wait, yeah, never mind.
Okay. So let's see. That would be 25. I'm already squaring. 25 minus 16. That would be 9. So that means that height right here is 3. So base times height, 8 times 3, 24. Half of that would be 12. 32 plus
I see
12,
what I did wrong.
44. Okay. Number 9 is 84 square units. Number 10 is 60 square units, 60. Number 11 is 16 square units. Number 12 is 19 root 3 square units. Number 13, 30 root 2 square units. Number 14 is 18 root 3 square centimeters. And 15, I think we did this one in class, didn't we, yesterday? 15? Was that weird one, 25 root 3 over 2?
We didn't do any. We went through classroom exercises.
Okay, I thought we did. I thought I allowed you to pick a number between 1 and 5, or it was Ben, and then we did 3 of them.
That was for classroom exercises.
Okay. 27. Let's see. 27 is 40 and 20. Those are the areas, and those are in square units. And
For which
30,
one? 40.
40 is A, B, C.
Okay, yeah, never
And
mind.
20 is A and B. And then for 32, A through D, A is 480, B is 240, C is 120, and D is also 120. And that was it. All right, clear this off and we'll get going here. Yesterday we had 3 formulas. Today we only have 1. I'm actually going to give you 2 formulas, but they're all for the same shape. So I'm going to give you 2 formulas for 1 shape. So there's your homework.
So I've been looking through the book since Jack's not here to do it, and today looks very, very simple.
And you know how they make it harder is they simply just put really bad numbers. But you are correct. It's a formula that we've already used in 7th and 8th grade. We just never proved it. The second formula we have never seen before. It's a simple formula. All right, here we go. Areas of trapezoids. Areas of trapezoids. Recall the trapezoid. Quadrilateral, that means 4 sides, where 2 of the sides, just 2, not 3, not 4, 2 of the sides are parallel. Those parallel sides, right? That's the definition of a trapezoid. It's quadrilateral, one set of opposite sides that are parallel. Those 2 parallel sides are called the bases. The bases. So we have identify on a trapezoid the 2 parallel sides. We call those the bases. The perpendicular distance between those 2 bases is called the height. And lastly, we didn't have this in 7th and 8th grade. So up to now, this is just all 7th, 8th grade stuff. We never named the other 2 sides. Take a guess. The other 2 sides are called? Anybody?
Left and right. I mean, legs.
They are called the legs. All right.
I knew.
So we have legs, we have height, and we have bases. And with the exception of legs, you've seen that before. A couple things I want to point out. One, these are your 2 just standard trapezoids. One where the parallel sides are top and bottom, one where they're left and right. Notice, doesn't matter where the parallel sides are, we still call those 2 parallel sides the bases. There are two special kinds of trapezoids. One is called take a guess.
A right trapezoid.
One is called a right trapezoid, obviously, because it has a right angle. By the way, since these are the two parallel sides cut by this transversal, if this one's 90, then so is this one. So it actually has two right angles. No math book ever draws those two right angles. They only just draw the one. But absolutely positively, that other angle, the angle directly above the other right angle, is also right. For the well, a couple reasons. Two parallel lines cut by transversal, then same side interior are supplementary. That's one way to prove it. Well, then that side would also be 90 because alternate interior. Then you have two angles that form a linear pair. There's another way of proving it. But bottom line is there's two of them. The picture will only ever depict one. The second one looks like this, where the two legs are congruent. We will call this one
Isosceles trapezoid.
Oh my word, you need to eat shrimp for lunch every day. Very good. Or you're reading from the book, one of the two.
No, I just remember this from I think chapter 4.
Right, that's correct. Okay, so there's nothing other than obviously the unique features of right trapezoids and isosceles, but they're still trapezoids. You still have one set of parallel sides. All right, a quick note, it doesn't matter which of the two sides that are parallel that you call base 1 and base 2, right? I can flip those around and call the long side base 1, or I can call the long side base 2. It's entirely up to you of whether you call the long side or the short side base 1 or base 2, your choice, okay? Sometimes in the book, they will distinguish the distance of those two bases as so. They'll draw a little red line that goes between the two vertices, and they'll label it with its distance. So instead of saying B2, B1, they'll have a number there, and obviously that just means the distance. All right, so let's prove that the formula for area of a trapezoid is 1/2 times the height times the quantity, base 1 plus base 2, right? This one's actually a pretty easy one to do. Here's what I'm going to do. I'm going to make a diagonal. I'm not going to make a rhombus, but I'm going to make a diagonal between either D and B or A and C. I'll just choose DB. Either one would work. Now, it looks like we make two triangles. In fact, we do. I want to point out that those two triangles are not congruent, right? This one in green, ADB, is not congruent to DCB. They look kind of close, but they're not congruent. But those two triangles added up together would be equal to the whole trapezoid. All right, so that's how I'm going to start. My first point is I'm going to say that the whole trapezoid is equal to those two triangles added together. That's that standard postulate 19 that says the area of the large shape is equal to the non-overlapping parts added together. All right, now I do want you to notice that of those two triangles, I don't know, maybe I'll color them again. I have a green one. I didn't do anything there. I have a green one, and I'll have a blue one. So green and blue. All right. On the green one, it's really easy to see that the height is h. What isn't easy to see is that on the blue one, if I extend DC, I'm just extending it, and then drop a vertical from B perpendicular down, I also get exactly the same height. So it turns out for both triangles that the heights are equal to each other. What's different is the two bases. Now, the two bases are definitely not equal to each other. So when I rewrite this portion, just using the formula for area of a triangle, 1/2 base times height. For the green triangle, I get 1/2 times the base, which is B1 times height. And for the blue triangle, plus 1/2, the base now is B sub 2, and the height is still h. And that's just using a little bit of a substitution and the fact that the formula for area of a triangle is 1/2 base times height. Very last step, how do we turn it into, all we're doing is factoring out the common things. So the common things in that 1, 2, 3, 4th line down there, the common things are the fact that both of those terms have a half and both of them have an h. So if I factor out an h and a 1/2, I wind up with the last thing, which says what we wanted to say, which is area of a trapezoid is 1/2 times the height times the quantity base 1 plus base 2. And there's your proof. Now, I actually could prove this to a 7th or 8th grader. I just choose not to do this. So once again, I usually say, hey, it's been a long formula. I'll prove it to you in high school. But this is one of the ones that a 7th or 8th grader could wrap their head around. All right, so what do you need to do? You need to write down this theorem, which is theorem 11.5, which states that the area of a trapezoid is 1/2 times the height times the quantity, base 1 plus base 2. That second one there in yellow is just a more calculator-friendly one. Instead of multiplying by 1/2, we divide by 2. So h times base 1 plus base 2. Some math books will put the h on the other side of the parentheses. Either one is fine.
But that's illegal. You always put it on the right side. That's like an unspoken law.
I'll say that the book that I have in for 7th grade, they put the h on the right side, and for the 8th grade, and then obviously for this book, they put the h on the left side, and it's the same publisher. So it's like they can't make up their mind where they want the h. And luckily for us, multiplication is commutative, so it doesn't matter which side. 3 times 2 is the same as 2 times 3. Now, we use this formula a lot in 7th and in 8th grade. Is it a memorable one? No, it's not too memorable. It's also the one that's on every state test and on the resource card. So it's one that you don't necessarily have to have memorized. In 8th grade, I basically gave you a trapezoid. I gave you the 2 bases, and I said, there's the height calculated. So you plugged in the numbers. The height was 7. The 2 bases are 8 and 12. We followed some PEMDAS. 8 plus 12 is 20. Half of 20 is 10. 10 times 7 is 70. So that would be what it would look like in 7th or 8th grade. You guys took this in 7th grade. However, you're in geometry now, and so for geometry, well, we're going to throw everything in there. We're going to use Pythagorean Theorem. We're going to use special right triangles. It's the same thing. Just be ready for it. Notice there's also not a picture. So watch me do this one. It says, find the area of an isosceles trapezoid. So I'll draw a pretty poor isosceles triangle. Well, there's my isosceles triangle. I know that an isosceles triangle, that the 2 legs are congruent. It says that the bases are 6 and 10. So obviously the long base is 10. The short base is 6. And it says the legs are 5, legs plural, because it's isosceles. So both sides are 5. All right. It says find the area. Well, to do the area, we use the formula. Let's see. Area is equal to, I'm going to use the calculator friendly one. The height times base 1 plus base 2, all divided by 2. All right, McKinley, let's plug in what information we know. What information do we know?
All we know is that base 1 is 10 and base 2 is 6.
Yep, and we don't know the height. So oops, I'm not sure why I'm writing that. I want to write, instead of that, I want to write 6. So I'll use base 1 as the top, base 2 as the bottom. So 6 plus 10. I don't know the height, but I do know it needs to be divided by 2. So let's see if we can figure out the height. If I had to draw the height suspiciously, I shall draw it right here. And I said suspiciously, as that gives me a right triangle. And if I draw this height over here in the same spot, we can see that we get another right triangle. And both of these triangles, well, the height would be here and it would be here, and both those triangles are congruent, hypotenuse leg. Therefore, all I really need to do is figure out the area of either one of these triangles, and I'm there. We got a problem is that because this distance right here isn't labeled, and that would be the same as this distance right here. Okay?
It would probably be 4.
Well, the total would be 4, so that means this individual piece would be
2.
There you go. And
Yes.
now draw a right triangle over here so we can see it a little bit easier. That would be 2, that would be 5, and we're solving for the height. So go ahead, McKinley, tell me what to write.
10 equals 4 plus
What
h.
equals?
10 equals
What
4
equals?
plus 10.
What?
10.
What?
10. You have to square 5.
I agree to that statement.
Well, and squared 5. Oh, it's 25.
All right.
Equals 10. No, 25 equals 4 plus h squared.
Keep going.
And then you get 21 equals h. Then you square root 21, which is,
Any perfect squares inside of 21?
I don't think so.
No, well, that's what we're going to plug into our formula. So you just found out that h was the square root of 21. So we plug that in. And now we do the math. 6 plus 10.
16.
So we get 16 root 21 over 2. Therefore, final answer, reduce the fraction, we get
8 equals 21.
what?
8. 8. You reduce 2 and 16, you get 8.
Okay, and what else did you want me to write?
Oh, 8 square root 21.
There you go. And
I've
that
only
would
said
be
that before.
that would be in square units. All right.
Oh yeah.
Well, there you go. You guys tore through that one really quickly. Here it is, nice and pretty. I'm not sure why I changed it and did it by hand, but I get a little bored. All right. Very good. Very good. Very good. Let's do some more challenging ones. All right. Hey, recall that if we done trapezoids, as McKinley said before, recall that we talked about way back in chapter 5, we talked about this thing called a median of a trapezoid. And a median of a trapezoid is a line or segment that goes to the middle of the two legs of a trapezoid. And we also found out that that when you do that, it ends up being parallel to the two bases. So MN is parallel to SR and PQ. And the other thing that 519 says is that we can actually calculate its distance. I don't know if you remember this part, but we take the two bases, we add them together and divide by 2, and that equals the median. Do you remember doing that at all?
No.
Okay.
No,
Well, we
not
did
really.
it. That was in chapter 5. We also remember we did the triangle median, and the triangle median said that the triangle median said that this median right here is 1/2 of this side right here, and then all we did was extend that to trapezoids. All right. So what has this got to do with anything? Well, I want you to look at what I just circled in red. Well, that would be the two legs. I'm sorry, the two bases. In other words, that would be base 1 plus base 2. Does that look familiar to you? Base 1 plus base 2 divided by 2?
Almost like it happened in 7th grade.
Almost like it happened 2 minutes ago. In what formula?
The theorem 519 formula.
No, this is theorem 519.
Oh, the median formula.
No, 2 minutes ago, we were doing another formula. What was that other formula?
Oh, the area of a trapezoid.
Yeah, the area of a trapezoid, right? We saw that the area of a trapezoid has inside of it base 1 plus base 2 divided by 2. In fact, well, here is the area formula, and there is the median. That whole big, long, ugly thing that 7th and 8th graders hate is actually the median. Now, I can't do this to 7th and 8th graders because they're not advanced enough, but for geometry students, I can. So instead of writing this big, long, ugly thing right here, we could simply write the height times the median. So this third one, also write this one down. This is an additional formula for area of a trapezoid. You simply take the height and you multiply it by the median. So we actually now have, it's not 3, it's 2 formulas. We have the standard formula for area of a trapezoid, 1/2 times the height times base 1 plus base 2. And then we have this alternative, right? Since the median is equal to the two bases added together divided by 2, instead of writing all that mess, we could simply write height times median and you're done. So why do we need all these formulas? Well, sometimes we'll be given the median, sometimes we won't. When we're not given the median, well, then we got to use the standard formula. But if we're given the median, well, why don't we just use the median formula? It would make our lives a whole lot easier. And that's what we're going to do. Okay, you guys got this written down?
Probably.
Okay.
Yes.
All right. For me, this was kind of mind-blowing. The fact that this big, long, ugly formula is just simply the height times the median. It was kind of crazy. I couldn't wrap my head around it, but it actually ends up being true. All right, let's see how this works in real life. Notice it says, what is the median? So I'm solving for median. What is the median of a trapezoid whose area is 300 and whose height is 10? So let's see, what are we given here? Well, here's the formula that involves median if I want to solve for it. So I need, if I want to solve for it, I need area, which I do. It's 300. So I could put 300 right here. I need the height. It says the height is 10. What I don't have is m, but I mean, look what I just wrote. It's a simple one-step equation. Therefore, the median is how big?
30.
There you go. Look how easy that was, right? That's crazy. Why don't they teach this to 7th, 8th graders? I don't know. They could if they wanted to. But remember, we were able to understand that really quickly because we've already done work on medians of a trapezoid. 7th and 8th graders don't do that. So that's why they don't get this one. But that was pretty simple. Let's do a more challenging one. Notice in this one, doesn't say just the median. It says, tell me the height and the median. Tonight for homework, these will be the more challenging ones. So I need to find the height and the median of a trapezoid whose bases are here and whose area is here. So this is going to require the use of both formulas, right? What do you mean both? I mean this formula right here, the standard one, and the alternate one, right? Well, the alternate one, let me write it for you, was area is equal to height times the median. So we're going to need both of those formulas. We're going to plug in what we got. Well, I know that the two bases, so this part and this part, are 27 and 9. I don't know the height, I don't know the median, but I do know the area. So I can plug in those things into my formula. So I'm going to plug in those things. Well, notice I only have one variable, so I can solve this. 27 and 9. $36, thank you.
I did.
Half of
I was gonna
36.
get
Half of 36 is
13.
18.
18.
And you're going to have to trust me that 90 divided by 18 is 5. Okay. All right. Well, that was cool. We just found out the height. So we just found out that the height, that right there, is equal to 5. I still don't know the median, but I do know that the area was 90. So once again, it's a simple thing to solve for the median. Simply divide both sides by 5. 90 divided by 5 would be what? 1 with 4, 18, right? And there you go. So there's my median, and there's my height. That was pretty easy. Tonight for
Wouldn't the
homework.
median just be 27 plus 9? Because I remember in the formula it says height times base plus
So
base
what's
2.
27 plus 9?
Yeah, that's 36.
But you got to divide by 2. That's also.
Oh, okay, yeah. All right.
And by the way, I'll clear all this mess. I did it the same way you just said. So I did it this way, and then I'm also pointing out, like you did, was that we could have found the median using that other formula right there, and that is true. All right, so just like yesterday, I can't do this trick now because now you know the trick. I can't have you pick a number between 1 and 5. But we can do a couple of these. So go ahead and open up your books to page 436. There's one of those ugly tables. And there's a bunch of other problems. So let's do a couple of those together. So Ben, you get to pick first. Pick something from the table that looks hard.
Ben, where are you, Ben? Ben?
I'm right here.
He's looking.
Yeah, I am looking.
Oh, okay.
I see no problem with this.
Okay.
What about number 3? That one looks a little.
Number 3.
Number 3 is
Not
ugly
that
only
bad.
because the numbers are ugly, right?
Yes.
All
Once you get yeah.
So let's see. I need both formulas. So here's the first one. Let's see. Area is equal to height times base 1 plus base 2, all divided by 2. And then the second formula, area is equal to height times the median. All right. Now let's plug in what we got. Now, each one of these are fractions. I'm going to write them as mixed numbers. So let's see. Base 1 is what? 19 over 6. So 19 over 6. I don't like that, but we got to deal with it. Base 2 is 13 over 3. Put those in parentheses. Do we have the height? We do. It is 8 over 5. And lastly, we got to divide that by 2. All right. This looks messy, but it's not too bad. I'm going to point out that notice it's pretty easy to get common denominators. The common denominator here is 6. So the only one I have to change is this fraction right here. So I'm just going to double everything. So I get 26 over 6. That color didn't work out too well, but you get the right idea. All right. So 26 over 6 plus 19 over 6. Let's see. Well, 8 over 5 is still 8 over 5. But 19 and 26, 10 and 26, 36, plus another 9 is 45. So I get 45 over 6. So you're okay with what I just did there?
Yes.
And that whole thing's over 2. You're going to find out that, look, some things cross cancel, right? So this 5 goes away. That 45 turns into 9. 2 goes into 6, 3 times? And 2 goes into 8 4 times. Now we multiply across. Oh, wait, I can do another reduction. Look, I got a 3 and a 9 right here. So 3 goes into 3 once, 3 goes into 9 3 times. So look how easy this one goes. 4 times 3 is 12. So we get 12 over 5. All right, don't panic. That's just 12. Why did I write a 5 there? That's supposed to be a 2. Oh, I hate when I make mistakes. All right. Yeah, that was over 2, not over 5.
It's just 6. The area is just 6.
Exactly. So that would be a 2. So the area is just 6. So that was easy. And that would be in square units. I'm looking at the book to make sure. Yep. All right. And so the last one, let's see. Well, using this formula right here, we know that the area we just did it was 6. We know that the height was, what was it? Height was 8 over 5.
Uh-huh.
Okay, so the height is 8 over 5, and that's all times m, the median. So we'll do a quick copy dot flip here. So multiply both sides by 5/8. Put that over 1. 5/8. The 8s cancel, the 5 cancels on that side, and on this side, anything cross reduce? Yep. That turns in 2 goes into 6 3 times, 2 goes into 8 4 times, 5 times 3 is 15. We get 15 over 4. So m is equal to 15 over 4. And the book says the answer is 3 3/4, and that is 15/4. Cool?
Yes. Cool.
All right. Well, that one wasn't that hard. It just was just ugly numbers. But go ahead, Ben. Pick anything from what's the other ones I gave you for homework tonight. I gave you what? 1 through 21.
21.
All right. So pick something else.
You know what? Let's do number 21, because why not?
Ooh, going risky there, Ben.
I know.
No idea what I'm saying.
We will need our calculator for this.
Oh my.
This one's going to involve some trig. All right. So 21, we got a trapezoid. we're told that this angle is 40 degrees. That's why I know I need my calculator, because it's not going to be special right triangle. There's plenty of special right triangles tonight for homework. But that one's 40. It's isosceles, so this side's 10, this side is 10. This side is 6, so we're missing base. I don't know if you want to call it base 1 or base 2. I'll call it base 1. All right, so we are, use calculator, find the area. Okay, so we know that area is equal to, calculator friendly, the height, which is not listed. So we got to come up with that. Base 1 is 6. We don't know what base 2 is. I'm sorry. We know base 1. We don't know base 2, or vice versa. Oh, I messed that up because I called it base 1. So we do know base 2. We don't know base number 1. So here we go. All divided by 2. Okay. So let's see. Obviously, our picture is missing the height. So let's draw the height.
I'm guessing it probably has something to do with tan.
Well, if this side right here is 6, right, and it's isosceles, that means from here to here is also 6. That leaves us with this unknown side right here. We'll draw that triangle off right here for just a second. That's horrible, but you get the idea. That side is 40 degrees. This side is 10, and we would like to find this side. So let's see. This side is the hypotenuse, and this side in relationship to 40 is the opposite side. So what trig function uses the opposite and the hypotenuse?
The sin.
There you go. So sine of 40 would be equal to the opposite, which is h, over the hypotenuse, which is 10. A little bit of algebra here. Multiply both sides by 10. So we get 10 sine 40 is equal to h. Ben, you got your calculator handy? Or McKinley, either one.
7.45, which I rounded up to 7.6.
All right. Not that I don't trust you, but I'm doing it myself too. 10 sine 40. And what did you get?
7.451131,605.
And you rounded that to?
7.6.
All right. I want you to hit your mode button on your calculator and tell me what are you in? Are you in radians or degrees?
I was in radians.
There you go. There's your problem. Try it again.
Ah, okay, it's 6.42.
So about 6.4.
Yeah.
All right. So
only off by like a number and 1,000 milli.
So we're going to call the height 6.4. You know, we could now, if we wanted to, we could figure out this little piece right here. We'll call that one x. All right. Because remember, we still need base 1. So let's do that. So I'm going to call, I need a different color. We'll call this side x. So I need a trig function that has adjacent and hypotenuse.
That is now tan.
No, that is not tan. Adjacent and hypotenuse.
Oh, cosine.
Cosine. So we have cosine 40 is equal to the adjacent, which we call an x, over the hypotenuse is 10. Hey, it's the same deal. So it's just 10 cosine 40 is equal to x. And that gives us
8, because I rounded.
Let's leave it as 7.7. Right, rounding it to 8 would be just too far off. So we'll round it to 1 decimal place. So x is equal to 7.7. If that's x, then this is x. So the whole darn thing, base 1, would be 7.7 plus 6 plus another 7.7. What's that give us?
21.4.
See what I'm doing over here?
Yes.
All right, type that whole darn thing in your calculator. See what you get. That should be the area.
21.4.
Make sure you use parentheses.
I wasn't actually typing anything. You get 87.68.
And the book says that the answer is, wait for it. I'll write it in blue. The book says the answer is 87.8. What did you get?
87.68.
Okay, so here's the, I mean, don't panic if you're looking at the odd ones. You're like, wait, why am I a tenth or two off for the trig ones? It's because we rounded to the nearest tenth on our intermediary steps. Like right here, we use 7.7. If we were to use 7.66, whatever it was, we would get a much more accurate answer compared to the book answer. But we got the right answer. That was a lot of work. All right, how are we doing on time here? 40 minutes. Oh, we're playing. We can do one more. Pick one of the special right triangle ones to do. That would be
14.
12 through 14. All right, let's do 14. All right, 14. So you get this shape like here. You're told that this side is 6, and by the way, right angles. So it is a trapezoid, by the way. That side 6. This side is 9 root 2, and this is 45 degrees. All right. So I don't know what you want to call 6, base 1 or base 2, but I'll call this side base 2. Notice the height here would be right here since it's a right trapezoid. So all we need to do is figure out how long is base 2. Well, if I extend this right here, well, from here to here would be 6. So we just need that piece. So in other words, on the special right triangle, it's 45. We know that the hypotenuse is 9 root 2. We just need to figure out how long is this piece. We'll call it A. Guesses? And that's a 9, not an A.
A would just be 3, wouldn't it?
Remember, on a special right triangle 45, 45, 90, you got legs A, and hypotenuse is A root 2. So guess what A is here?
9.
A is 9. So this piece right here, from here to here, doesn't look that way, but that piece right there is 9. So 9 plus 16 would be base 2. That's what, 15? All right, and now we have everything we need. So, oh, no, we don't have H. Ooh. Oh, yes, we do, because it's a 45, 45, 90, so that would be H, and that would also be 9. We got everything. All right, so area is equal to the height. The height, which we just figured out, was 9. Base 1 is 6. Base 2 is 9 plus 16 is 15. And all that divided by 2. So let's see. 6 and 15 is 21 plus 9. Plus 9, I meant multiplied by 9, I'm sorry. 6 plus 15 is what?
21.
Times 9 divided by 2.
189 and then divided by 2.
And we get?
You get 94.5.
And the book says that the answer is 94.5, and we got the same answer. Very good.
Who uses fractions anymore? That's so 3rd grade.
Yeah, so third grade.
All right. Well, that was everything that I needed to do with you guys. Be careful of those special right triangle. Let me just remind you. We just did a 45, 45, 90 special right triangle. So you get A root 2. And then for the 30, 60, 90, this side's 30. The side opposite 30 is A. The side opposite 60 is A root 3. And the hypotenuse is 2A. And these are questions 12 through 15 all deal with special right triangles. And since we did 14, you don't need to do 14. All right. Any other questions?
Nope, none for me.
All right.
None for me.
Finished with only about 5 minutes to go. That's good enough. I will let you go, eat some cookies or whatever it is we're doing, and I will see you guys tomorrow.
Goodbye.
Okay.
Have a nice day.
You as
Have
well.
a nice day.